Hello everyone. So this is your new video of the revision of calculus, right? So let's start. So the first question is the limit x tends to infinity cot inverse x to the power minus a and this log x on the base of a and a is greater than 1. So what will be the limit? So before starting, let's say what is the form of this limit. So limit of this form is if cot inverse infinity, that is sec inverse infinity, right? Okay, actually we don't know this is infinity or not, so we have to check, we can't say that this is sec inverse infinity and all. So we need to check for x tends to infinity, where this expression is approaching, for x tends to infinity where this expression is tends to, right? So what I did, I simply write it as a question that x tends to infinity. Okay, so let's use L'Hospital, right? Let's use it, L'Hospital rule. So I just change the log function x tends to a. So now use L'Hospital, that is 1 by x log ea and a x a minus 1. Okay, so what we can say, log ea a and x to the power a, right? So limit x tends to infinity. Sorry. So for x tends to infinity, this expression approach to 0. So this expression approach to 0. Okay. So now come to second expression, ax log xa. Okay, limit x tends to infinity. So I change the base, log ea and log ex, x tends to infinity. So now again use L'Hospital, ax and ln a already written here, and log x is 1 upon x, right? So ax x ln a whole square, limit x tends to infinity, right? Okay. Okay, now for x tends to infinity, this expression tends to infinity, this expression tends to infinity. This will try to approach to infinity, right? So what we can say, x tends to infinity, right? X tends to infinity is equal to 0. Okay, so what we can say, limit x tends to infinity cot inverse this approach to 0 and sec inverse this expression approach to infinity. So cot inverse 0 means that is pi by 2, right? That is pi by 2. Okay, cot inverse 0 is pi by 2. I'm right. Okay, right. Now sec inverse infinity, sec inverse infinity means pi by 2, sec inverse infinity means pi by 2. So the answer is 1. Okay, sec inverse infinity. Okay, the answer is 1, right? Let's go come to next question. So this is the answer, this is the final answer. Final answer is 1. Okay, this is not a very simple question. We can't simply say what is the form of this. We just try to evaluate the inner part, that for x tends to infinity where it stands to, right? The second question is very simple question. So it is written logarithm form. So we know log a plus log p is equal to log ab, so we'll use it. So solution, what we can say, we can simply multiply both. Okay, and sec x minus cos x. Okay, so limit x tends to 0. So this expression actually is the factorization of this. When you multiply this, you will get this x to the power 4 plus x square plus 1. You need to remember, guys, the factorize of x square, x to the power 4 x square plus 1. So let me write down. You need to remember it. 1 plus x square and into 1 minus x plus x square. You need to remember it. Okay, so now change sec into cos. 1 by cos minus cos x, limit x tends to 0, right? Okay, so it is like 1 plus x form. Okay, I can simply write it in this form and just take the LCM in the denominator. That will be cos square x and cos x, limit x tends to 0, right? So for x tends to 0, cos x is 1, so I will eliminate this, and by short trick which we discussed already in the first lecture, we can write ln 1 plus x is equal to x. So x square 1 plus x square, and this is sine square x. Okay, limit x tends to 0. Now I can write down x upon sine x square into 1 plus x square, limit x tends to 0. This is tends to 1 and this is also tends to 1, so answer is 1. So answer is 1. Okay, this is a very simple question. So come to next question. Okay, this is the question. Okay, what I will do, n x to the power n plus 1 minus n plus 1 x to the power n plus 1, right? E to the power x minus e sine pi x, limit x tends to 1. Okay, forget about the numerator part, come to the denominator part. What I did, this for x tends to 1, sine pi x tends to 0, but where it tends to pi x, for x tends to 1, pi x tends to pi. Okay, and I just simplify it in different form. Forget about the numerator part, right? For the time being, just take e common from here, e x minus 1 minus 1, and I can write down this pi minus pi x, pi minus pi x. So why I write down this pi minus pi x? So that pi minus pi x for x tends to 1, for x tends to 1, pi minus pi x will tends to 0. To make it 0, to make the argument of sine 0, I did this, I did this aspect that I need to subtract from pi. Okay, this is the formula 1, right? This is the formula that we have already discussed. Ex minus 1 upon x, limit x into 0 is 1. So I can simply write whatever it is written here. Okay, so nx n plus 1 minus n plus 1 xn plus 1. So I can write down e x minus 1, and I can simply write down this pi 1 minus x. Okay, we have already discussed these things, how to write sine x is equal to x and e power x minus 1 is equal to x. Okay, so limit x tends to 1. Okay, now come to numerator part. N xn plus 1 and xn minus xn plus 1, right? Just take xn common here, or e, it is minus pi 1 minus x square. Okay, I can write down this, it will be not a big deal, right? Now I need more page. Okay, let me use, so take this xn common here, and what you will get, and also common, x to the power x minus 1 common, x to the power n minus 1, right? Minus e to the power pi 1 minus x square. Okay. Now what I will do, I will just separate, or take x minus 1 common, better take x minus 1 common, and you can write this x to the power n minus 1 x minus 1 upon e pi 1 minus x square, or common part is written here, x minus 1. Okay, you can simply cancel this out. Okay, 1 by x square and x minus 1 will cancel it out, and 1 minus sign will be available. Okay, let me do here, let me do this here. Okay, okay, n x n. So this is actually written x minus and x power n minus 1 upon x minus 1 is written actually the GP summation formula, right? This GP summation formula. So it is written 1 plus x square up to x to the power n minus 1 and minus e to the power pi 1 minus x, 1 power will cancel and the minus will go also, right? Now again check the limit. Now again check the limit. Limit x tends to 1. Limit x tends to 1. Okay. Wait. Limit x tends to 1. So still this is 0 by 0 form. So what I do, I just simply use L hospital n n square x n minus 1 minus 0 plus 1 plus 2x up to n minus 1, x to the power n minus 2, right? And in the denominator e to the power pi minus 1. So now simply put x tends to 1. Now simply put x tends to 1. So it will be n square minus 1 plus 2 plus 3 up to n minus 1, up to n minus 1 upon minus e to the power pi. So n square minus n minus 1 n by 2 upon me. Okay, so this is the answer. Okay, this is the answer. Okay, if the value is given n is equal to 100, you can directly put n is equal to 100 here and you will get the answer here. Okay, I am just leaving here. Okay, you can solve further, I think, right? So it is not an easy question. So just take full consideration on my lecture so that you will understand it very easily. Okay, let's come to the next part. Let's come to the next part. Or sometimes you can use here binomial expansion by replacing x tends to 1 plus h. Then it will be more easy to you understand. Okay, but in my lecture you will find I will never use x tends to a plus h and a minus h like that. So next question is, limit x tends to 0 1 minus e to the power x sin x mod x. Okay, so what I can do, I just take this e to the power x minus 1 and minus sin x upon mod x greatest integer, limit x tends to 0. So I can write a to the power x minus 1 limit x tends to 0 is equal to limit x tends to 0 is equal to I can write down, I can write down this. So it will be minus x sin x mod x, right? Limit x tends to 0, right? Now just see here comes the mod. So we need to approach towards right hand limit and left hand limit. Okay, when we are discussing right hand limit, so we are approaching from 0 plus side. So this is minus x, or we can write down this is x, and this is also we can write x because x is positive here. So what you will get, you will get minus x, okay, or limit x tends to 0 plus. So you can write down this minus x limit x tends to 0 plus. So 0 plus, this will be 0 for 0 plus, for x tends to 0 plus mod x is 0. So your answer is minus 1 for RHL. Okay, we are talking about RHL. Now come to LHL. Okay, from here, we are now applying the LHL. Limit x tends to 0 minus. Okay, 0 minus means we are approaching from left hand side towards 0. Okay, so minus x is minus x, and this is x, and this will be minus x. Okay, I don't think you have any problem. So you can cancel out this. Limit x tends to 0 minus, it will be x. So x tends to 0 minus, x is negative, so the greatest integer of x negative, like well, the value of minus 0.01, it's minus 1. So answer is minus 1. So RHL is equal to LHL. So your final answer is minus 1. Limit exist. The final answer is minus 1. Limit exist. Now come to the rest the question. Okay, this is the question. Yeah, sorry, this is solution. Limit x tends to 1 minus. Okay, we are approaching from left hand side towards 1. 1 minus does not mean this is, we are negative, x is negative. Okay, 1 minus does not represent x is negative. We are approaching towards 1 from the left hand side. So 1 minus root x cos inverse x. Okay, x square, right? Okay, now see here, I can replace it. Cos inverse x is equal to theta. If x tends to 1, okay, if x tends to 1 minus, okay, if x tends to 1 minus, so let me draw the graph of cos inverse. It will be a decreasing function, so graph will be like this. Okay, graph will be like this, and this is minus 1, and this is 1. So we are approaching from this side. So cos inverse tends to 0 plus. Okay, cos inverse tends to approaching from 0 plus side. So x tends to 1. Cos inverse x is theta. For x, if x tends to 1 minus, theta tends to 0 plus. From graph you can see easily. Yeah, okay, from graph you can see easily. So just replace it. So what will be x? X is equal to cos theta. And root x is equal to this is root. Okay, now just x equal to cos theta. So okay, we are done here. Let me use now, we just rationalize this 1 minus x, 1 plus root x, and cos inverse x square. Okay, now replace x is equal to cos theta. Then theta tends to 0 plus. So 1 minus, and we can say 1 minus cos theta, this will be equal to 1 plus root cos x tends to 1, and this is equal to theta square. So this is our formula, 1 minus cos theta, theta tends to square. Okay, this is our formula. Okay, I think, okay, theta tends to 0. Okay, right? Okay, so our answer is 1 by 2, right? Our answer is 1 by 2, right? Our answer is 1 by 2. Okay, whenever you see this cos inverse terms, okay, simply replace it by cos inverse x is equal to theta, so that the picture will be more clear to you, right? Picture will be more clear to you. Okay, so our answer is half. Okay, right? Now our answer is not half. See, we didn't change x here. Okay, so let me use, we just did a simply mistake, very silly mistake. Okay, see, limit extends to 1, what for extends to 1, this is approach to 2, so I can write down this is approach to 2 cos inverse x square, right? Limit x tends to 1 minus. Okay, now replace it, and now replace it, x equal to cos theta, 1 minus cos theta 2 theta square, limit theta tends to 0 plus, theta tends to 0 plus, so answer is half, and the answer of this is also half, so your answer is 1 by 4. So your answer is 1 by 4. Okay, so this is the final answer. This is the final answer. Next, okay, next question. This is a very important question. Let me solve this. Before solving, let's understand the concept that we know sin x is greater than sin x. Is it true or false? This is false. Okay, we know x is greater than sin x. Why? Why? From graph you can easily see this is a sin x curve, and y is equal to x is approaching towards this, right? So y is equal to x, so x is always greater than sin x, in the interval 0 to pi. Okay, in the interval 0 to pi, and this is the graph, right? So x is greater than, so what I can say, x upon sin x, x upon sin x is greater than 1, x upon sin x is greater than 1, and sin x upon x is less than 1. Okay, sin x upon x is less than 1. Okay, right? Or you can draw the graph of sin x upon x. This is graph of sin x upon x. So this is empty circle here, this is empty circle, this is not defined at 0, so let's, okay, let me make it again. Let's make an empty circle and do this. Okay, so this is y axis and this is your x axis. For x equal to 0, this is not defined, so this is empty circle, and this is value is 1, this value is 1. So sin x upon x is less than 1 always, and x upon sin x greater than 1. Okay, so now x 100 sin x, it will be greater than 100, slightly, okay, slightly greater than 100, right? So greatest integer part of this function, greatest integer part of this function for limit x tends to 0 is 100, right? Is 100. Now come to second part. So sin x upon x is less than 1, so 99 sin x upon x is less than 99. So less than 99 means like 98.99. okay, 98.99, like this. Okay, so what I can say, the greatest integer part of this, the greatest integer part of this for limit x tends to 0 will be 98, right? This is less than 99, so this is less than 99 means 98.99. so greatest integer part of 98.99 is 98, and this expression, the first expression is greater than 100, slightly greater than 100, not 200, it will post not 200, slightly greater than 100, so 100.2, 100.3, like this. So the greatest integer part is 100, so the answer is 100 plus 98 is equal to 198. This is the answer. So answer is 198. Okay, now come to next question. Okay, we see sin inverse x, so we'll replace it by theta. Okay, in every question we will do the same thing, sin inverse x, whenever we see sin inverse x, cos inverse x, tan inverse x, cos inverse, we will replace it by theta. So sin inverse x is equal to, let sin inverse equal to theta, let So if x tends to 1 by root 2, then theta tends to pi by 4, right? If x tends to 1 by root 2, theta tends to pi by 4. Just simply replace it. Limit x tends to 1 by root 2, x minus cos sine inverse x, right? 1 minus tan sine inverse x. Okay, now replace it. X is equal to sine theta, this will be tan theta. X is equal to sine theta, okay, and minus cos theta upon 1 minus tan theta, right? Take cos theta common here, tan theta minus 1 upon 1 minus tan theta for limit theta tends to pi by 4. So it will be cancelled out and leave minus 1 sign. So your answer is limit theta tends to pi by 4 minus cos theta, so minus 1 by root 2, right? Minus 1 by root 2 is your answer. Okay, this is very simple question. Whenever you see sine inverse x, cos inverse x, whenever you see inverse function, just replace it, try to convert into trigonometric function. Okay, this question is very tricky one. Okay, if x1 is 3, x1 is 3, xn plus 1 to xn, right? This expression is given and n is greater than 1. Limit n tends to infinity, right? Limit n tends to infinity. Okay, let's say just simply find out the expression of x to the power n. Okay, just simply find out. Let's say x2 is equal to 2 plus x1, so you can say it will be equal to root 5. Okay, let's say x3 is equal to 2 plus x2, so it will be equal to root 2 plus root 5, right? And x4 is equal to 2 plus x3, so it will be equal to 2 plus root 2 plus root 5. Now x5 is equal to 2 plus x4 root, so it will be equal to root, okay, right? So similarly we can say for s tends to n, you will get the expression like this only. Okay, wait, you will get the expression like this only, 2 plus root 5, and then you get root 5. Okay, 2 plus, okay, and so on. So let's say this is n. Okay, so xn plus 1 also will be like this only. Like this only, right? Just the difference of one term only. This is the difference of one term only. If n tends to infinity, there are a lot of terms in this section involved. So there is no difference between 2x to the power n, x suffix n, and x suffix n plus 1. If n tends to infinity, there is no more difference in x to the power n and x to the power n plus 1. From this expression you can simply assume it. Okay, we can assume it, there will be no big difference in this expression and this expression when n tends to infinity only, right? Okay, so we considering it, if n tends to infinity, xn is equal to t and xn plus 1 is equal to also t. So we can assume it, if n tends to infinity, xn is equal to t. We can assume it. Okay, now apply limit formula on the given expression, 2 plus xn. Okay, apply limit on both sides. Limit n tends to infinity xn plus 1 2 plus limit n tends to infinity xn. Okay, so it will be equal to t, and we can say 2 plus t, right? Now simplify it by squaring 2 plus t. Okay, 2 plus t. Okay, now t square minus t minus 2 is equal to 0. Okay, okay, right? So factorize it, t minus 2 and t plus 1 with the factorization. T is equal to 2 because this expression is positive. Xn is always positive, so answer will be 2. So your answer is 2. Your answer is 2, right? I don't think you have any doubt. Still you have any doubt, just comment on the comment box. I will try to resolve it. So this question is very tricky one. We just need to see that x suffix n and x suffix n plus 1 for n tends to infinity, it almost equal. It's almost equal. Okay, it almost equal, right? Chalo. So the next question now comes to next question. Next question is limit x tends to 0, 1 to the power x, 2 to the power x, 3 to the power x, and n to the power x upon n. 1 to the x. If we check limit here, the independent form is 1 to the power infinity. The independent form is 1 to the power infinity, right? 1 to the power infinity. Okay. So what we do in the 1 to the power infinity form, we just add 1 and subtract minus 1. So I can write down add 1 and subtract 1, add 1 and subtract 1. Okay, now take this whole expression like this. Let me write down limit x tends to 0, okay, and n to the power x minus n, I took the LCM here, upon n into product of the power, which is x, product of the power, and this whole thing is on the exponential power, right? So this is the method to solve it, 1 to the power infinity form, right? Let me write it down, fx gx. If this is 1 to the power infinity form, you can simply write it down fx into gx, right? Now see here, limit x tends to 0, 1x minus 1, 2x minus 1, 3x minus 1, nx minus 1 upon x, and 1 to the power n. Okay, this is x. Okay, this is x. So what I did, I just simply split n into 1 plus 1 plus 1 plus 1 up to n times, okay. I just split and distribute each one to the each n terms, distribute each term to the h n terms. 1 to the power x minus 1, here comes 1, here 1 comes, here 1 comes, here, okay. So I distributed each one to the each term of the 1 to the power x plus 2 to the power x plus 3 to the power x and plus 2 n to the power x. Okay, just simply distribute it. Still the expression is same. So this is the formula. A to the power x minus 1 upon x is equal to ln a. Right? This is equal to ln a. So ln 1 plus ln 2 plus ln n upon 1 by n, right? Upon 1 by n. So your answer is E ln n factorial 1 upon n e to the power ln n factorial to the power 1 by n. So your answer is n factorial 1 by n answer. Okay, so this is your answer. Chalo, let's come to the next question. Okay, here one next question. Okay, so this is the 1 into power infinity form solution. E 1 minus e, this is not a greatest integer. Okay, 1 by e x upon 1 plus x limit. This is the 1 to the power infinity form, right? This is 1 to the power infinity form. Okay. This 1 to the power infinity form, just simply take like we did above, that we add 1 and subtract 1, and I will directly write down this. What we will get, it will be x e 1 minus e 1 upon e x upon 1 plus x minus 1. You will get this. Okay, so multiply it. Okay, just multiply it. Okay, I'm just solving this part, and then finally we will put it in the power of the exponential. I'm solving on this part only. So let's say limit x tends to infinity x, okay, 1 minus e to the power x 1 plus x 1 minus e minus 1, right? Okay, now club this minus 1 with this expression. Let's see what we get. 1 minus e minus 1 e to the power x 1 plus x 1 minus e. Okay, so you will get 1 minus e to the power x 1 plus x 1 minus e x limit x tends to infinity, limit x tends to infinity. Okay, now this cancel out, so you will get e to the power x 1 minus e minus e to the power x 1 plus x 1 minus e. Okay, I think I'm right till now. X to the power, or this will be x square. Okay, this will be x square. Now take common e 1 upon e 1 upon e is common, x minus x square 1 plus x. Okay, limit x tends to infinity. Now just simply take LCM of this. E 1 minus e x plus x square minus x square upon 1 plus x. So it will be cancelled out, and limit x tends to infinity, still valid. Limit x tends to infinity, e 1 minus e x upon 1 plus x. For x tends to infinity, x upon 1 plus x tends to 1. So your answer is e 1 minus e. So your answer is e upon 1 minus e, right? Okay, so these questions are very level 2 question. In the previous lecture we have discussed the question of the level 1, which are very easy, right? These questions are very tricky one. Okay, now come to the next question. Solution fx ln x square e to the power x ln x to the power 4 e to the power 2x, right? So this is ln infinity plus upon ln infinity form. We can say infinity upon infinity form. So what I'm trying to do, just say, let's see. Okay, we can see e to the power x and x square, which one is greater? Okay, it's, you know, it's very clear, e to the power x is greater than x square, right? E to the power x is greater than x square. You can solve it by differentiation. let y is equal to e to the power x minus square, differentiate it, e to the power x minus 2x, e to the power x minus 2x. Okay, for x equal to 0, this is positive, right? And for x greater than, between 0 to 1, still this is greater than, between 0 to 1 it is still y dash is positive, and after x equal to greater than, it is very obvious y dash is always positive. So y dash is positive for all x belong to R. So we can say okay, we can say that this is an increasing function. So this is an increasing function, right? This is an increasing function. So e to the power x1 greater than hoga x1 square, right? This is the greater. Okay, this is an increasing function, right? So it's always, we can say e to the power x greater than x square. Let's say now take common e to the power x 1 plus x square upon e to the power x ln e to the power 2x common 1 plus x to the power 4 e to the power 2x. Okay, now you can write down and ln e to the power x plus ln 1 plus x square e to the power x, right? Now the denominator part you can write 2x plus ln 1 plus x to the power 4, or you can say x square e to the power x whole square, right? You can write down this limit x tends to infinity, limit x tends to, this is x. Okay, in question it is written n, actually this is x, this is actually x tends to infinity, right? X tends to infinity. So now for x tends to infinity, where this expression tends to, okay, for x tends to infinity, where this expression tends to, so use L'Hospital, 2x e to the power x and 2 e to the power x. So this expression tends to 0, this expression tends to 0, right? So you can simply say x plus ln 1 plus x square e to the power x 2x ln 1 plus x square e to the power x whole square. Okay, x square upon ex tends to 0 when x tends to infinity, right? So this whole expression is 0, this whole expression is 0. You can write down ln x tends to infinity, x upon 2x 1 by 2 is the answer. Why this expression is 0? Because x square upon ex is 0. So ln 1 plus 0 is ln 1 is 0, right? So answer is half. Okay, so I think this is the no, this is we have still so many questions. Okay, let me do this. It was simple one. It is a simple one. This is written here, cot pi by 2 root a minus x a plus x. Okay, this extends to a 0 0. This is 0 into infinity form. This is 0 into infinity form. I will try to convert it into 0 by 0 form. So what I did, I just simply make it 10 a minus x up a plus x. Okay, and this expression for x tends to a, this expression tends to 0. So I can eliminate 10 from here. I can directly write down pi by 2 root a minus x a plus x. Okay, we have already discussed this, why I just eliminated this 10. Okay, now you can split it a minus x and root a plus x like this. So a minus x and root a plus x, it will be cancelled out, and pi by 2 is still here, and x tends to a. So if for x tends to a, the answer is, it will be pi by 2 is will become 2 by pi, and it will be a plus x for limit x tends to a. Your answer is 4 upon pi. Okay, 4 upon 4a upon pi, sorry, 4a upon pi, 4a upon pi. It was very simple. Now okay, this will take time, so for time being I think we should stop here. Okay, the 3 questions are remaining. You can note it down and try yourself at your home, and you can comment me if you didn't able to solve it, right? It will be difficult, and this will be very easy question. You can simply find out the minimum value of this. Okay, and we have already discussed this question in the above, and it is also very simple question. This is not p, it is actually pi. Make it right. It's not p, actually this is p. So you can solve these 3 questions. This for your homework, and I will make a short video for these 3 questions. Okay, so for this lecture, okay, thank you, and we'll meet you again. Thank you.